All right, we are going to be working on our graph. I'm going to step away from my computer. Hopefully you can still hear me. I'll try and yell a little bit. We're going to mark off a couple things on our graph. First thing I'd like you to notice is the y-axis, just like in our notes before. This is force in pounds, and notice how high this went before it broke. Here our max force, 439 pounds. So it got pretty high before it snapped. And this is our displacement, or how much it stretched as the test began. Let's label a couple things. Let's see. Let's just label our force, and let's label our displacement. Remember, it's like an unfinished 8. First thing I'd like to find on my graph is where, I know this line wobbles a little bit, but it's pretty straight, and it really starts to curve right here. And then I'd like you to draw a line straight down. So that's what we call our elastic limit. I'm going to go jot some stuff over here on the right. That's our elastic limit. And then we're going to shade this in. This is our elastic region. This is also sometimes called the proportional limit. And then our elastic region. Basically what this is saying, if the test were to stop at any point from the elastic limit down, the original material, the dog bone, would go back to its original shape. It would snap back into place. Think about a car bumper. You could hit a car bumper with a fair amount of force, a plastic car bumper. You could hit that with a fair amount of force and it would pop back to its original place. So that elastic region is pretty important to someone designing, again, something like a car bumper or a bike helmet. Next thing I'd like to talk about is this thing called yield point. Yield point is 0.2% or 0.002 of the elastic limit. Let's write that. I think we have some room up at the top. So we'll call our elastic limit 375. Go over, that's about 375. So if we do 375 times 0.2%, so that would be 0.002, you're going to get 0.75. If I add that back to my original, I'm going to get 375.75. That's pounds. Notice that that's not much larger than our elastic limit. Imagine the yield point is like a line in the sand. From that point forward, the material will no longer behave elastically. So we're going to put a little dot, just barely beyond our elastic limit, and we'll call that the yield point. I'll do that in red, just like that. So that's our yield point. Okay. Moving forward in our graph, make sure you underline or circle this maximum force, and that's right here. And this part is where the sample broke. So our force increased, and then started to taper off, then went down, because right here is where it snapped and broke. That's called our rupture point. So we'll call that max force. Just do that little arrow like that. Rupture. And then I'd like you to connect the 2 like this. in that area, that is what we call our necking region. Just like I spoke about in the video, that's where the dog bone is actually starting to reduce its area. And then one final thing is our plastic region. Plastic region is that area in red, and it does include the necking region.